All right, guys, hope you're doing well. Here's your warm-up. You know what you should do by now. Pause it, try it out on your own. Once you have an answer, come check your answers. I'll put them up here. These are the 4 answers that you should have gotten. For the first one, if you got all 4 of these correct, you can pause and skip over this. If not, for the first one, you should be thinking of condensing this log. So there's a plus right there, which means that when we condense it, we're going to be multiplying different things. I would work in the parentheses first because this is log base 5 of x minus log base 5 of y. We divide because of that minus, so it's x over y. And then since this 3 is the coefficient, it becomes the exponent using the power rule. And then we can distribute that to the third to the numerator and denominator. So you get log base 5 of x to the third over y to the third. And then we can combine these two because of that plus, and you will get 2x to the fourth in the top and y to the third in the bottom. Okay, so that's where I got this final answer from. For part B, it's just natural logs. We're going to use the same thing. You should have, since this is a plus, we can multiply 5x minus 3 and 2, so you get 10x minus 6 in your natural log. In order to solve that, I'm going to switch forms. We know a natural log has a base of e, so I'm going to make it e to the 10th equals 10x minus 6. Add 6 and then divide by 10. I put both answers here, the approximate and the exact answer for you. For part C, subtract 7. We're trying to isolate the exponential part. So subtract 7, divide by 4, so we get 5/4. Because it's a base of e, we're going to take the natural log of both sides. The ln of e, they wipe out, and we get just 2x minus 2 comes down out front. And then we have the ln of 1.25 or 5/4 on the right side. Add 2 and then divide by 2 for the whole thing. For the last one, it's a application problem. It says you deposited $5,000 into your account, compounds continuously, so that means we're using our APERT formula here. Your principal is 5,000. You're looking to double it, so you're going for 10,000, and then you divide by 5,000 at each side, so you get 2 there. Take the natural log of both sides because we have a base of e, so you get ln of 2 equals 0.082t. Divide by 0.082, and you should get 8.45 years. Okay, so there's your warm-up. You should be good with those. You guys did your check-in on that last time. Today we're going to talk about something called arithmetic sequences, and we're also going to talk about series for them. So you guys in your last lesson were introduced to sequences and series. So this is not said as arithmetic, it's arithmetic, okay? First thing, identifying these things. In an arithmetic sequence, the difference of consecutive terms is constant. The constant difference is called the common difference, and it's denoted by D. Okay, so if you look at this first sequence, in the first one right here, to get from 8 to 5, we subtract 3. To get from 5 to 2, we subtract 3, subtract 3, subtract 3. My common difference here is -3. So I would say, yes, this is an arithmetic sequence. Okay, because D equals -3. For the next one, if you look here, it looks like they're all perfect squares. So here we're adding 3, adding 5, adding 7, adding 9. We're not adding the same amount each time, so no, this is not arithmetic. You guys try these 4 out on your own. Pause the video, try them out. Once you're done, play the video. I will have the answers right here. First one's going up by 7 each time, so it's arithmetic. Second one's going down by 8, and then 6, and then 4, and then 2, not arithmetic. C going down by 6 each time, arithmetic, and D is not arithmetic. Next thing you're going to do is we're going to talk about writing rules for these different things. So you're going to have a formula right here. It says writing rules for arithmetic sequences. The nth term of an arithmetic sequence with the first term a sub 1. And the common difference D is given by this thing right here. So here's your formula that we're going to use. Okay, this a sub n means the nth term. So if I say a sub 4, that means the 4th term in the sequence. If I say a sub 1, this is your first term. Okay, so we're going to have a first term every time, and then we're going to have a common difference. Okay, so when we look at an example of that, just so you have something to relate back to, it says example 1, the nth term of an arithmetic sequence with a first term of 3 and a common difference of 2, so that's my D, is given by, and we're going to write out the formula. So the formula says a sub n equals a sub 1 plus n minus 1 D. I said the first term is 3, so that's going to go in for a sub 1. And we're just trying to write out a formula for it. So a sub 1 is 3 plus n minus 1, and my common difference is 2 here. We are not going to leave it written like that, so we're going to distribute this 2 in, and you're going to get 3. This will become 2n minus 2. And then when you combine like terms, we'll end up with a sub n is equal to 2n, and then the 3 minus 2 will give me plus 1. So that means if I asked you what the 16th term was in this sequence, we would say a sub 16 would be my n, because I want to know the 16th term. I would plug in 16 for n, so we would get 2 times 16 plus 1. That would be 32 plus 1, 33. So the 16th term is 33 for this sequence. Okay, so that's for arithmetic sequences. So if I look at this next one right here and we want to try the same thing, we want to write out a rule for it. If we look at this, my starting term, a sub 1 is equal to 3. I know it says you try. We'll do the first one together. You can try out the next one on your own. The starting term is 3. And then my common difference, I'm going up 5, up 5, up 5. So when I think back to my formula, it was a sub n is equal to a sub 1 plus n minus 1 D. A sub n is going to be equal to 3, which is my first term, plus n minus 1. The common difference was 3 here. I'm sorry, the common difference was 5. That was my D. And then when we multiply this out and distribute, we get 3 plus 5n minus 5. Combine your like terms. A sub n is equal to 5n minus 2, which means that if I ask you for the a sub 15, the 15th term, a sub 15, we're going to plug in 15 for n. 15 times 5 is 75 minus 2. That would be 73. So I would write this out as a of 15 is equal to 73. And if you think about this, if we were to graph something like this, and I made a graph, let's say that here is the n and here is a sub n. The first term, a sub 1, or that when n is 1 would be, let's see, when n is 1, we get 3 out, 1, 2, 3. Our second term is 8, 2, 3, 4, 5. Our third term is 13, so 1, 2, 3, 4, 5. It would look something like that. And if you keep graphing this, it kind of looks like a line. Your slope is 5, and your y-intercept, or where we started out, now not technically your y-intercept here, is 3. Now, we have to be careful. This is not a line because there's nothing in between here. We don't have a 1.2 term or a 2.5 term. We have nothing like that. This is called discrete. Okay, so it's not continuous. It's just going to be a bunch of points together. I want you guys to try the next one. Use the same formula. We have your first term. You should be able to get your common difference. So pause this video, try it out. I will go ahead and show you what the answer should look like. If you got a sub n is equal to negative 8n plus 63, then you did it right. What you should have found was your first term is 55. Your common difference was negative 8 because you were going down 8. If you plug those into your formula and then distribute it out, you had negative 8n plus 8 here. Combine your like terms, 55 and 8 is 63. So we get negative 8n plus 63, which means that your first term was 55. And if I ask you for the 15th term, then we would plug in 15 right here. Negative 8 times 15 plus 63 will give you negative 57. Okay, this is going to be similar to how back when you guys were writing the equations of lines, because we do have the same common difference. However, this is discrete, like I said, so the points are not connected. They're just separate like that. For example, number 2, this is saying one term of an arithmetic sequence is a sub 19 equals negative 45. This means the 19th term is negative 45. The common difference is negative 3. So we need to think back and we need to figure out what we started with, because your equation says a sub n is equal to a sub 1 plus n minus 1 times d. So for this, we need to think about what we have and what we still need to find out. If we take the information that you have, I know that a sub 19, when I plug in 19, I got out negative 45. So I'm going to think of that. I'm going to say a sub 19 is negative 45. I don't know what my first term was, but I do know that the n that I plugged in, the 19th term, was negative 45. So I'm going to plug in 19 for n. So we're saying n equals 19. A sub 19 was negative 45. And then my common difference I know is negative 3 right here. Okay, so we need to be careful. We're not subtracting through here. This is multiplying by negative 3. So what I'm going to do here is I'm going to distribute in that negative 3. And that's going to give me negative 45 equals a sub 1. 18 times negative 3 is negative 54. We're going to add 54 to both sides, and that's going to give me a sub 1 is equal to 9, which means that the first term in this sequence is 9. Now, that's not what we needed, but we do have the information we need to write the formula, because a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is going to be equal to 9, which is my first term, plus n minus 1 times my common difference, which is negative 3. Distribute in, multiply it all out. You should get a sub n is equal to, let's see, this will be n plus, that'll be negative 3n. And then negative 3 times negative 1 is positive 3. Combine your like terms, a sub n is equal to negative 3n plus 12. And if we really wanted to check our answer, we could plug in 19 here. And we could say we know the 19th term should be negative 45. So if you plug in 19, that's going to be negative 3 times 19 plus 3, or plus 12, I'm sorry. And that gives me negative 45. Now, if I ask you for the first 6 terms, well, we know the first term, if we plug in 1, we know that our first term here is going to be your a sub 1 with 9. So the first term is 9. If we plug in the second term, well, we know my common difference is just going down 3, so this next term should be 3. But you could also plug in 2 right here, because we're doing the second term. N is the number of the term. So negative 3 times 2 is negative 6 plus 12, gives me 6. And then if we keep using the common difference, go down 3, down 3, down 3, and down 3, and that gives you the first 6 terms. You could plug it in again, but we can also just use the formula if you wanted to. Example 3 is going to be similar to that. However, I said 2 terms of an arithmetic sequence are a sub n. The 7th term is 71, and the 16th term is 26. So it appears that your numbers are going down, because if the 7th term is 71 and the 16th term is 26, and you're going down some amount each time. We don't have a sub 1 here, the starting term, and we don't have your common difference. So we're going to have to figure out the common difference. In order to find the common difference, you're going to think of it as the slope. So we're going to think of this point as 771, and we're going to think of this point as 1626. The 7th term is 71, the 16th term is 26. And if you think back to your formula for slope, which is our common difference here, that was y2 minus y1 over x2 minus x1. Okay, and we plug some numbers in here. You're going to have 26 minus 71 over 16 minus 7, which gives us negative 45 over 9, which means my common difference here is negative 5. Okay, so that means we're going down 5 each time. Now you still need to figure out your starting term. So we're going to go back to how we did the prior question. So I went to my formula, and we can pick one of the points. I'm going to pick this point for now. Actually, no, let's pick the other point. They're smaller numbers. Let's pick this point. And let's say our formula is a sub n is equal to a sub 1 plus n minus 1 times d. I know my common difference is negative 5. I'm going to say that 26, which is what I'm plugging in here. We don't know the starting value, but we know it's the 16th term, and then my common difference is negative 5. So when we multiply this out, 16 minus 1 is 15. 15 times negative 5 is negative 75. So I have 26 equals a sub 1 minus 75. Add 75 to both sides. A sub 1 is 101. Okay, so when I write out the formula, the rule for this sequence, a sub n is equal to 101 plus n minus 1, and my common difference was negative 5. Multiply this out, and then combine like terms, we'll get a sub n is equal to 101 minus 5n plus 5 when I distribute that negative 5n. Finally, you should get negative 5n plus 106. So that means you start out with 106 and you go down 5, or you go down 5 each time. So if I asked you for the 15th term, you would plug in 15 for n and then solve it all out. Again, you could check your answer by making sure the 7th term is 71 and the 16th term is 26. 2 of these for you to try out. For part A, you can look back at this example 2 that we did. For part B, you can look back at example 3 that we did. So make sure you have to find your a sub 1 first. For this one, you have to find your common difference first, and then find a sub 1. Answers are right here. If you're still unsure, go back and check how we did example 2 and example 3. Pause the video now, try these 2 out. Here are my answers for it. For A, you have to make sure that you plug in 11 for n. So it should be 50 equals a sub 1 plus 11 minus 1 times your common difference. Solve that out. Your first term is negative 20. So you plug that back in, plug in your common difference, multiply it all out, and then move everything around, and you should get that rule. For part B, same thing. Find your slope first. Find your common difference. So y2 minus y1 over x2 minus x1 using your slope formula. Simplify it all out. Get your starting value, your first term in the sequence. Plug it back in, multiply it out, and you should get 4n minus 11. Okay, one more thing we need to talk about, and that is about the sum of finite series. So a finite series means a series that ends at some point. It's not going on forever. Maybe it's a certain number, four numbers in the sequence. Series means we're adding them all up. So it says the sum of the first n terms of an arithmetic sequence is given by this formula right here. Okay, and let's say it is a series that has 4 terms, then that means that n would be 4. Okay, since it says S of n is the average or the mean of the first and nth terms multiplied by the number of terms. So here's the number of terms. If you think about adding 2 things up and dividing it by 2, that's where we start talking about the average or the mean. Okay, so if I gave you something that was 12 terms, we would add up the first term and the 12th term, divide it by 2, and then multiply by however many terms we had. Okay, so if we're trying this out, we want to think back to that formula that I have right here. So this first one says, find the sum of the series. I'm telling you that we're starting at 1, and there are 20 terms. Okay, so my formula said S of n is equal to n a plus 1 plus a sub n over 2. Okay, and then from here, we know that there are 20 terms. So my n is 20. I do need to know the 20th term. I need to know my first term and my 20th term. So if you plug in to get your first term, the first term in this series, I'm going to plug in 1 for I. So a sub 1 is going to be equal to 3 times 1 plus 7, which gives me 10. But I also need to know what the 20th term is, the last thing when we put it in there. So when I plug in, when I plug in for a sub 20 is going to be equal to 3 times 20 plus 7. Well, 3 times 20 is 60. 60 plus 7 is 67. Okay, so when I plug that into my formula, a sub 1 was 10, a sub 20 was 67, and I'm dividing by 2. So I'm finding the average of the first term and the last term. So add them up and divide by 2. If you multiply this out, you should get 10 plus 67 is 77. 77 divided by 2, and then multiply that by 20, and you should get 770 for this. Okay, so that means if you take the first term, and then you take the second term, and the third term, and the fourth term, and the fifth term, and keep adding them up until you get to the 20th term, they will total to 770. Now you could do that by hand, it would take you a while, but you could say the first term is 10. If you plug in 2, the second term would be 3 times 2, which would be 6 plus 7, that would be 13. And then you take the third term would be 16. And you take the fourth term would be, 4 times 3, 12, 19. So we're going up by 3 each time, and keep adding these up until we get to the 20th term, which is 67. That will all add up to 770. So this formula gives you a quicker way to do it. For example 5, we're going to do a little real life example of this now. It says write a rule for the number of cards in the nth row when the top row is 1. So if you look at this picture right here, we're stacking cards up there as a pyramid. If you look at the first row, the first row has 3 terms. The second row down has 6 terms. The third row down has 9 cards. So it's going up by 3 each time. So if you look at that, my common difference here is 3. And if we need to write the equation for that, I'm going to go back to how we did it before. We have the common difference. We know that the first row we're starting out with is 3 terms. So a sub n is equal to a sub 1 plus n minus 1 times d. A sub 1 is 3. My common difference, I'm going up by 3 each time. N minus 1 times 3. Distribute it out, solve it out. You get a sub n is equal to, 3 plus 3n minus 3. 3 and 3 will cancel. You'll just get 3n. So if I ask you how many cards are on the 4th row, there will be 12 cards. How about the 5th row? There will be 15 cards, and so on and so on and so on. For the last one here, it says how many cards you need to make a house with 12 rows. So how many total cards would you need? That means I'm adding them up. So this is a series here. We're not talking about a sequence. We need to add up each row of cards. So I'm going to say summation. I say I'm starting with the first row. I'm going up to the 12th row. So starting in the first row, going up to the 12th row, we're going to add up all the cards each time. So I'm going to say it's 3i because it's going up a common difference of 3. Okay, we got that from this prior formula right here. I have my formula that says S of n is equal to n times a of 1 plus a sub n divided by 2. I want to know how many cards do we need for the 12th row. I'm saying that my n is 12. And then in the first row, we start out with there are 3 cards. But for the 12th row, we have to have, let's plug in 12. See how many cards we need. 3 times 12 is 36. So I have 36 for the 12th row. Find the average of that, 36 plus 3. divided by 2, and then multiplied by 12, you should get 234. So 234 total cards are needed if we want to make a house that has 12 rows. So 3 in the first, 3 more, or 6 in the second, 9 in the third. Keep adding them up, adding them up, adding them up until you get to the 12th row, and you should get 234. From here, one more thing, your exit ticket. Try it out. We did one question like this already. Pause it, see what you get. Here's the answer. I gave you 2 terms. So first you find your slope. Pick one of the points, plug them in, get your starting value for your sequence. Then you have your formula. From there, I'm asking you for a sub 20, so you plug in 20 to find the 20th term in the sequence. Last one says the sum of the first 20 terms, so I want to find the value for the first term and the 20th term, average them up, divide by 2, multiply by the number of terms, 20, and you should have your answer. For your assignment, it's going to be these questions. It says 2 to 10, 14 to 20, 24 to 28, 32 to 38, evens only. So you should be doing 2, 4, 6, 8, 10, 14, 16, 18, 20, so on. Only do the even questions. The answers are up there for you guys to check on Schoology.